We begin with section 1.1, Introduction to the Practice of Statistics. Our objectives include define statistics, explain the process of statistics, distinguish between qualitative and quantitative variables, and then we'll distinguish between discrete and continuous variables. So we start by defining statistics. We encounter statistics in our daily lives more often than we probably realize, and from many different sources, like the news. Typically, when you read a newspaper article or watch a television news program, you're given sample information. With this information, you decide about the correctness of a statement, claim, or fact. Statistical methods can help us make the best educated guess. So our main goal in statistics is to collect data from a small part of a larger group so that we can learn something about the larger group. With a formal definition, we say that statistics is the science of collecting, organizing, summarizing, and analyzing information to draw conclusions or answer questions. In addition, statistics is about providing a measure of confidence in any conclusions. And we talk more about that confidence much later in the semester. So we start with a definition. We can say that data, you can say are, but data in general is observations that you or someone else records, numeric or non-numeric. And we'll differentiate between the types as we move through this lesson. A population is the entire group to be studied, and a sample then is a subset of the population that's being studied. So our goal is to take a sample of people from the population to try and determine something about the population. We want to maximize good results as conveniently as possible, so we don't want to try to survey the entire population. It costs too much, it's too time consuming, so we'll work at different sampling methods. To explain the process of statistics, we start with a note. In statistics, we collect data by taking a sample from a population and then organize the data using charts and graphs so that we can analyze the data and make an inference about the population. Definition here, a statistic is a numerical summary of a sample, right? So we've got that alliteration highlighted in bold there. A statistic describes a sample. Our course is going to be broken into two parts. We start with descriptive statistics. And descriptive statistics consist of organizing and summarizing data. They describe data through numerical summaries, tables, and graphs. And then we'll move into inferential statistics, which uses methods that take a result from a sample, extend it to the population, and measure the reliability of the result. Definition here, a parameter is a numerical summary of a population. So again, we have that alliteration. A statistic describes a sample, a parameter describes a population. For the example here, we're going to determine whether the given value is a parameter or statistic. So in a poll of 1,010 adults in the United States, 55% of the respondents said that they used local TV stations daily as a source of news. We can say that this 1,010 adults is a sample of all adults in the United States, so we'd call this 55% a statistic. For B, after inspecting all of 55,000 kilograms of meat stored at the Wurst Sausage Company, it was found that 45,000 kilograms of the meat was spoiled. Since we are looking at all of the meat stored there, we're looking at the whole population of meat, so this 45,000 kilograms that was spoiled is a parameter. We'll move on to distinguishing between qualitative and quantitative variables. For our definition, we start with a qualitative or categorical. Variables allow for classification of individuals based on some attribute or characteristic. So we're categorizing or associating by a quality. Examples include hair color, blood type, ethnic group, the car a person drives, street a person lives on, anything we can use to categorize someone. And then our other definition, we have quantitative. Variables provide numerical measures of individuals. So some examples, amount of money, pulse rate, weight, number of people living in your city, age of respondents, all these are numerical values that we can track. And quantity kind of leads to that number. And then we'll distinguish further between discrete and continuous variables. So note here, quantitative variables can be further broken down into discrete and continuous variables. We start with a definition of a discrete variable is a quantitative variable that has either a finite number of possible values or a countable number of possible values. Think of them as a result of counting. They cannot take on every value between any two possible values, and that's what we're going to use to kind of distinguish between the two when we do have an infinite number of possibilities. Some examples include the number of eggs that a hen lays, the number of phone calls you receive for each day of the week, number of books in your backpack, so something we can count up or put in order. Definition here then, a continuous variable is a quantitative variable that has an infinite number of possible values that are not countable. Think of them as the results of measuring. They can take on every possible value between any two values. So some examples include measuring angles and radians, the weight of your backpack, the area of lawns on your street, something we can measure, and then really you can think of as something we can always refine the measurement for. So we can't put it in order. We can't say this weight comes after the next one. It's not just 150 pounds and then 151 pounds. We can go to 151 and a half or 150 and a half, whatever that would be in the middle there, 150.52, right? We can always refine and go a little bit deeper, so we can't put the numbers in order. And let's try a few of these together to finish off this first section. We're going to determine the correct data type here, qualitative or quantitative, and if they are quantitative, we'll go to discrete or continuous. You're welcome to pause and try it first, or just play along. The number of pairs of shoes you own. Since we're tracking a quantity, this is going to be quantitative. I'll just put, how about quant? And then since we can count up the number of pairs, this would be discrete. The type of car you drive, we're looking at a quality, a type of something. So I guess I can write out all of qualitative. Where you go on vacation, we can say another category or qualitative. The distance it is from your home to the nearest grocery store, since we can measure that distance, it would be quantitative, right? Numerical, and then continuous. The number of classes you take per school year. Again, we're talking about a quantity of something, so we can go with quantitative, right? That number. And then since we could count these up, it would be discrete. The type of calculator you use is just a quality. Right, we can go by brand or for function, scientific, graphing. Political party preference, also something we can categorize, so qualitative. I wrote quality, but same thing. Weights of sumo wrestlers, we can actually measure this, so we'd have a quantity, so quantitative. And then continuous for this one, right? We can always measure that weight. Well, it's not like the pounds I used already earlier. Number of correct answers on a quiz, so we're definitely quantitative. And since we can count up the number we get correct, this would be discrete. And for the last one, time it takes to run a mile, we are measuring a quantity, so we've got quantitative and continuous. All right, try some stuff. Reach out if you got questions.